Hi students, in previous class we observed the calculations related to the order, and now here with respect to first order, if we have an idea about half-life, as per the previous models what they asked in previous examinations, these are the relations. By using log values we calculated, and I am trying to give the relations in a simple way to remember, and where you have to apply if that question is going related to this type of models. So for that, just try to understand and have a look. If half-life is T, then what is time for 10% completion or 30% completion or 90%? So like this we calculated, and I am giving those values in front of you. So now among all these, just here, this is one important relation, T20 and T60. T75 already, that is a well-known relation, 2 into half-life, and 287.5, 90 and 93 and 96. Okay, and these are common relations, these three. So try to remember those values, and automatically you will get the answer within fraction of seconds. See, for example, suppose in any first order, if half-life is 10 seconds, so what is the time required to complete by 90%? Means 3.32 into 10 means 33.2 seconds. Very simple. Otherwise, you have to go for the log values and the relations between T90 and T50. So it will take time. So try to remember as many as possible by having a proper practice. If you practice these relations as like formulas, you can remember. And finally, see here, this is the ratio between four important percentages, that is T90, T99.1, T99.99 and T99.99. So they are in 1:2, 2:2, 3:4 ratios. Even if you observe the corresponding values, you will get that relation. So try to use this format to answer those questions in a simple way. And sometimes they are not going to mention the ratio directly. They used to mention as the fraction, like 15/16 or 14/15, like that. Then just simplify the 15/16, automatically you will get the corresponding ratio in percentages. So like that, try to use this analysis in a simple way. So this is the way how you have to solve this type of questions in a easy method. So try to practice 1 or 2 times, and automatically the relations will be recorded in your mind. Okay, that is regarding the relation. And now we will go for, as I said in previous class, we will go for the graphical analysis related to the order, means in kinetics. So for that, here, as you know, we have one important theory, that is collision theory. So according to that collision theory, here there is one important analysis, means they used to give in the form of graph. See, for example, this is the progress of the reaction, and here we are having the reactant A, and the progress of the reaction, it will be like this. See, for example, this is the reactant and it is the product. Now, based on this, if you understand this graph, whatever the crest here we are getting, this is nothing but activated complex. So this is one activated complex. And after that, here we are getting another activated complex. And now if you observe this graph, it represents an intermediate product. So now in this graph, generally in this type, the troughs are representing intermediate product and the crests are representing activated complexes. So you have to remember that. And after that, based on this graph, Here, just imagine the process is in two steps. First, R is converting into X as intermediate, and then X is converting into main product. So means it involves in two steps. If there are two crests, the reaction is going to involve in two steps. If there are three crests, three steps. So like that, among the two, which is slow and which is fast. So for that, just observe activation energy. So this is the original energy of the reactant, and this represents activation energy, EA1. And here this is intermediate, it is the original energy of intermediate product, and this is the activation energy in second step. So now, if you want to analyze which is fast and which is slow, very simple. Generally, speed of the reaction means the rate of the reaction that is inversely proportional to activation energy. If activation energy is more, that is slow step. If activation energy is less, that is fast. So in this graph, no doubt the second step means the conversion of X to P is fast, whereas formation of that intermediate product is slow. So this type of analysis you have to keep in your mind. And now if we observe this energy difference, this is the energy of the reactant and it is energy of the product, and this is what we call as delta H. Of course, in this energy of the product is less, means while R is converting into P, on overall some amount of energy is releasing, means it is exothermic process. Means if the position of the product is below the reactant, exothermic. Suppose if the position of the product is above reactant, if it is like this is R and it is P. So definitely energy of the product is more. So that graph represents endothermic process. So be clear about this type of analysis. And now another one, we'll go for calculation related to the graph. Means the way how they are giving the information. So for that, here just I am giving some examples. Here there is a process A3 that is converting into 3A, and they mention as first order. This is first order. Now the variation of concentrations they are giving like this. This is concentration, and here concentration of the product that will be increased, and this is concentration of the reactant. Okay, now here the point what they are asking, suppose if you observe this point of intersection, this is time t. So at time t, what fraction of the reactant is going to be complete, or what is this time t? Either it is half-life or 20% or 10% or 30%, that we have to find out. So for this process which follows first order, at this intersecting point, means if you observe the time interval, what is this time? That we have to find out. So for that, one thing you have to remember, at point of intersection, concentration of the reactant and the concentration of the product both are equal. So that point we have to use. See this. At this point, both the concentrations are equal. So for that, just see here, A3 is converting into 3A. Suppose initial, let it be A. Involved is X, and it will be 3X. That is in time t. So after time t, remaining is A minus X, and it is 3X. So now at time t, what is the condition? A minus X equal to 3X. So A minus X equal to 3X, or 4X equal to A. So therefore X equal to A by 4. Means in time t, the decomposition of reactant is 1/4. 1/4 means 25%. So as per this, time t is nothing but T1 by 4. T1 by 4 means T 25% in this process. So that is the answer what we require. So just to see here, only one point here you have to remember. At this intersecting point, the two concentrations are going to be equal. So this is one model. And next, another one, if you observe, that is third one. Here the information what they are giving is like this. That is AN, which is also first order. So now AN is converting into NA, and this time is 30 hours. This is 30 hours. In this graph, this is AN. And based on this, here we have to find out half-life of the substance. So now, according to this, then what is half-life? That we have to find out. And here also, go for the analysis, that is AN gives rise to NA. Suppose if it is A, involvement is X, here it is NX, and remaining is A minus X, and here it is NX. Because we are getting, sorry, here it is not N, this is 4. This is 4. They are giving A4 as 4A. So now just I am going to say this is A4 and 4A. If it is X, it is 4X, and it is also 4X. Now at 30 means at T equal to 30 hours. What is the condition? A minus X equal to 4X or 5X equal to A. So therefore X equal to A by 5. A by 5 means that is almost 1 by 5, 20%. So here according to this, T 20% equal to 30 hours. So this time is 30 hours, but we require T off. Previously we observed one relation. T 20% equal to 0.322 into T half. So therefore T half equal to T 20% by 0.322 means 30 by 0.322. It is around approximately 93 hours. So according to this, the half-life of that substance is nothing but 93 hours. So in this way, first to find out what is this time. So here we are getting this time is nothing but T 20%. So if you know T20, by using this relation, we will find out half-life. So this is another important model. Okay, and next we will go for fourth one. Now here it is nothing but AN, that is converting into NA. Here it is AN which is converting into NA. Now in this graph they mentioned T. This is T. Now the information what they are giving, if this T corresponds to the time at which 1/6 of the reactant is going to decompose. So this T is 1/6. Okay. So if it is like that, then what is the value of N? N means here it is not order. Just we have to find out the coefficient for that substance. So here also just observe what will happen during decomposition. So AN, it is converting into NA. Suppose if it is 1, here since they mentioned as 1/6, here I am considering 1. So in time T, 1/6 was decomposed. Here it is nothing but N by 6. Now the remaining is 5 by 6, and this is N by 6 after time T. Means at this intersecting point. So now at T, what is the condition? 5 by 6 equal to n by 6. So therefore n equal to 5. So that molecule is having the formula of A5. So it is also the same concept. At which means that at intersecting point we have to equate the constant concentrations. This is one simple model. And the last one regarding this graphical analysis. Here A3, the reaction what they are giving, let it be 5. A3, that is converting into 3 by 2 A2. 3 by 2 A2. And this is the graph what they have given. Means this is A3 and it is A2. And this time, as per that graph, this is intersecting point time. Now the information is at time t, what percent of A3 is composed. So now at time t, the percentage of A3 decomposed. That is what we have to find out. Means how much of reactant is going to decompose, or otherwise what is this T? Either it is 10% or 20% or 30%, that we have to find out. So for that, just see here, this is A3 which is converting into 3 by 2 A2. Initially let it be A and environment is X. This is 3x by 2 and remaining is A minus x at time t, and this is 3x by 2. As usual, at time t, what is the condition? A minus x equal to 3x by 2. So therefore A equal to 5x by 2. Here we will get plus x. So as per this, x equal to what? 2 by 5 into A. 2 by 5 means that is 0.4 into A. So therefore percentage, that is 40 into A. 40 into A. So that means at time t, 40% of the reactant is going to decompose. Therefore T equal to T 40%. So like that, here by using this graphical information, we have to go for the corresponding values. But in all these models, one thing you have to remember, at point of intersection, the concentration of both reactant and the product, they are equal. Just by using that concept, as per the analysis, we are getting. So like this, as the trial classes, just I am going to conclude this kinetics with this part, and in regular classes we will go for in detail. Okay, so try to utilize these concepts what we discuss in 3 classes, especially for chemical kinetics. No need to worry about the chemical kinetics. It's a very easy part. Just you have to find out the key point in the given problem or in the given question. So if you have that ability, automatically this topic is very easy topic. So try to utilize all these things. Thank you. Hi students, today we will go for one of the important concepts, especially related to the acidic solutions and of course basic solutions also. That is nothing but pH scale. So now, as you know, pH, it is nothing but the power of hydrogen ion concentration. Of course, that is in terms of logs, that pH is nothing but minus log H plus. See, the purpose of this pH scale is, especially if you want to express the concentration of solutions, we are using the powers like 10 power minus 1, 10 power minus 4, 10 power minus 6, like that. So, they are very minute. That means to avoid those minute values. And of course, we are using minus 10 power minus 3, 10 power minus 2, like that. So to overcome this difficulty to express those minute concentrations, here Sorensen, he introduced an important scale, that is nothing but pH and of course pOH also. But here one thing you have to remember, we are going to observe regarding pH scale, means that is in terms of Hc plus ion concentration. Similarly, if you observe pOH, that is in terms of the concentration of OH minus ions. So almost both are same, but here we are using the pH scale in terms of H plus ion concentration. So now if you observe pH of the solution, generally it is nothing but minus log H plus, means its concentration. Of course it is base 10. So this is the fundamental formula for pH. That means if you observe that formula, if you get the concentration of H plus in the given solution, directly we can substitute that value. So thereby we are going to get pH value. Now in general, suppose if you observe that pH scale, here it is 0 to 14 at 25 degrees centigrade. That is at 25 degrees centigrade, because kW is 10 power minus 14. So as per that, here we are having 0 to 14. Now in between we are having 7. pH is 7. So if pH is between 0 to 7, they are acids, means acidic solution. Whereas if pH is between 7 to 14, that is basic. And after that, suppose if you observe middle value, that is 3.5. So up to 3.5 they are strong acids, and above that they are weak. And after that, here what happened? 10 to 10.5. Here 7 to 10.5. Here it is weak base, and near to 14, that is strong base in case of basic solutions. So anyhow, that is the pH scale at 25 degrees centigrade. Now suppose if temperature of the solution is going on increasing, means the relation between pH and temperature. So what will happen? Generally pH is going on decreasing if temperature increases. The reason is, if temperature is increasing, the dissociation of acid will increase. So thereby concentration of H plus is going on increasing. If concentration of H plus increases, pH value is that will be decreases. So that is the relation between the pH and temperature. Now here one of the important thing what you have to understand, how to get the concentration of H plus ion. So for that, just if you observe concentration of H plus, generally in case of strong acids, here concentration of H plus ion, that is nothing but its normality. Normality will be equal to concentration of H plus. Or otherwise, if they mention molarity, that is molarity into basicity of the acid. So like that, directly for strong acid we will get the concentration of H plus. Suppose if it is base, normality of that strong base is equal to OH minus, or molarity into acidity is known as OH minus. So like that we have to use this concept. And sometimes to find out H plus, here we are having one important concept, that is ionic product of water, means here Kw equal to H plus into OH minus. So therefore concentration of H plus, that is nothing but Kw by OH minus. So like this also sometimes you will get concentration of H plus. So anyhow, in case of strong acid, that H plus equal to normality or molarity into basicity, and in terms of anechoic of water, here it is nothing but Kw by OH minus. Now, in case of weak acids, if you observe weak acid, here for weak acids, generally if you observe concentration of Hc plus, that is nothing but C into alpha, where C is the concentration of the acid and alpha is degree of dissociation. And if you know alpha is nothing but root K by C, so if you substitute that expression, Hc plus will be equal to root K into C, because here alpha equal to root K by C. So if you substitute this expression here, we will get root K into C. So like this, in case of weak acids, either C alpha or root K into C. So like that, first you have to get the concentration of H plus present in the given acidic solution. And after this, see, since strong acids, H plus equal to normality or molarity into basicity. So after that, pH equal to minus log H plus, that is common. Now, in case of weak acids, if you observe this formula, since H plus equal to root K into C, so for weak acid, we will get direct formula. For weak acid, here pH equal to minus log root K into C. That means it will becomes half into pKa minus log C. That is the formula to find out pH of a weak acidic solution. And sometimes if they have given dissociation constant and degree of dissociation. So here next point, if Ka and alpha has given. So as per that, here pH equal to pKa minus log alpha. That is the formula for the pH directly if you want to use that value of Ka and degree of dissociation. So like this, directly we have to get H plus and finally pH. But in any solution, if you observe sum of pH and pOH, that will be equal to pKw. Sum of pH and pOH, that is equal to pKw. So now at 25 degrees centigrade, this sum of pH and pOH. See, at 25 degrees centigrade, Kw is 10 power minus 14. So then pKw is nothing but 14. So this is one important relation what we have to remember. This is at 25 only. So sometimes if you observe the statements, at all temperatures, sum of pH and pOH will be equal to 14. Is it correct? No, that statement is wrong. At all temperatures, sum of pH and pOH, that will be equal to pKw. That is correct. But it will be equal to 14 only at 25. Suppose if temperature increases, sometimes it will become 13.5 or 13 or 12. So like that, it will be decreases. Since by increasing temperature, the concentrations of H plus and OH minus, they are going on increasing. So that is regarding the relation between pH and pOH of the solution. So this is how to get pH for either strong acid or for weak acid. Now, here another important point what we have to understand, that is what will happen to the pH of a solution on dilution. So that means here relation between pH and dilution. Now I am explaining in terms of acids with respect to acid. So now just see here, this is dilution and H plus means concentration of H plus and pH. So if you observe this, Suppose if the solution is going on diluting, concentration of H plus that will be decreased. See, for example, if dilution is by 10 times, if dilution increases by 10 times, means we have taken 1 ml and we made it to 10. That is the meaning. So, if dilution increased by 10 times, means volume increased by 10 times. If volume increased by 10 times, H plus concentration is going on decreasing by 10 times. If H plus concentration decreased by 10 times, pH will increase by 1 unit. So, it is going on increasing by 1 unit. That means, just I will give the clarity. Suppose there is a solution whose pH is, for example, 3. Now that was diluted by 10 times. What is the resultant pH? Of course, that final pH after dilution, that will be 4. Because 10 times dilution. So definitely pH is going on increasing by 1 unit. Like that, suppose dilution is by 100 times. If it is 100 times, 100 times of that H plus concentration is going on decreasing. So thereby pH will increases by 2 units. Similarly, 1000 times. If dilution is by 1000 times. Now concentration of H plus decreases by 1000 times and pH increases by 3 units. So like that, that is the relation between dilution and the pH of an acidic solution. But here, I want to give one clarity. See, here it is dilution, thereby H plus going on decreasing. But we can decrease the concentration of H plus in 2 ways. One is by dilution or by adding a particular base. If you are adding the base, automatically H plus is going on decreasing. See, here I will show two, that means the same problem in 2 different ways. Means, see for example, here there is HCl solution. Example for this, HCl solution, which is an acid whose pH, let it be 5. This is the solution. Now, if dilution is 100 times, then what is the pH of the solution? Dilution means you are adding water, that's all. Means, as per the previous table, if dilution is by 100 times, then pH have to increase by 2 units. 2 units means it should be 7, but not like that. If it is 7, that is neutral. Even though 2 units are increasing, here for this HCl solution, the pH is not going to be 7. Because, do you think on dilution, an acid is going to convert into neutral or base? No, that is not at all possible. So, even though 2 units has to increase, here, this pH, it should be between 6 to 7. That's all. Or less than 7. Or pH that is going to be less than 7. Not only 2 times. HCl pH 5. If you dilute by 1000 times also, pH should be less than 7. Because don't forget, we are adding only water. Of course, on dilution H plus is decreasing. On dilution. Okay, this is one concept. Suppose another bit, if H plus concentration decreases by 100 times, then what is pH? Now you have to understand the difference between these 2 concepts. One is on dilution by 100 times, what is the pH? Definitely it is less than 7. Now here, the concentration of H plus decreases by 100 times. We don't know whether it is by dilution or by adding base. So that point here you have to understand. So definitely here the pH will be becomes 7. Means suppose it is by adding of base. Continuously if you are adding the base, definitely acid is going to get neutralized. If it is neutralized, then pH will be 7. So you have to understand this difference in these two concepts. Since it is acid, on dilution also it is exhibiting acidic nature. Acidic nature means the pH should be less than 7. But here what happened? Of course, it may be by the addition of base. So automatically it will get neutralized. So that point you have to remember carefully here. And next, another one, mixes. Suppose if you observe a mixer. See, just I am showing two examples for mixers. Now, imagine here there is a solution A and a solution B. We are going to mix. Here there are two statements. If the pH of these two solutions are between 0 to 6. So now pH range. If it is between 0 to 6, then pH of the mixer, that is equal to lower pH plus 0.3. That means here this is for two solutions. For two solutions, mixtures of two solutions of same volume. Means 1 liter of A, 1 liter of B. If you mix that, then the pH of the mixer is lower pH value plus 0.3. Now just I will give the clarity. Suppose A and B we mixed in same volume. Now its pH is 2 and its pH is 4. Between 0 to 6. So then for this mixer, if you observe that pH, it is almost 2.3. Yes. So the statement what we have to remember, if two solutions of same volume are mixed in the pH range that is 0 to 6, the pH of the mixer is 0.3 more than lower pH value. That is the meaning. Suppose if the pH range, if it is between 8 to 14, then the pH of the mixer, it will be equal to higher pH in that mixer, what we are using, minus 0.3. So higher pH minus 0.3. So like that you have to get the pH of the mixer instantly. But here, especially as far as the this concept concerned, for two solutions here we are adding 0.3. Suppose if you are mix 3 solutions, 0.45. 4 solutions, 0.6. So for 2 solutions it is 0.3. Here also same thing. So if you are mixing 3 solutions of same volume, that will becomes plus 0.45. Here it will becomes minus 0.45. So like that you have to remember this concept. So therefore instantly you will get an idea regarding the pH of the mixers. So this is the concept what you have to remember in view of auxiliary examinations, especially related to the pH scale. Okay, so based on this we will see the problems in next class. So try to understand the concepts and try to go for whatever the bits that you are having with you. Okay, thank you.